represent BSES Rajdhani Power Limited. It is distributing power in capital of India, Delhi. So our presence is in South, West, Central, and East Delhi. So BSES with two companies, BSES Rajdhani and BSES Yamuna, is catering about two-thirds of Delhi. So as you know, Delhi is very dense, and space is always a constraint for engineers to optimize. We, with the 50 million customer, 5 million customer, 50 lakhs customer in Delhi, more than 4,500 customers per circuit, per square kilometers, is are having like problem of expanding our network every now and then. Our demand is growing at the rate of about 5 to 6%, and meeting 5 to 6%, practically you have to add uh, about 6 to 8% of network capacity. And for those network capacity, again, you have to have space. Apart from the capex, you need to have a space. Now, space is limited everywhere and constrained, and with the cost of space growing every day, it is further difficult for the utility to acquire more space. As you also know that space is generally under the state control. So for space for new distribution substation, space for 66 by 11 or 33 by 11 substation is getting difficult. We route through government for getting space. We are getting space also, but the need versus the supply, the demand versus supply is getting widened every day. So what is the solution? Now, when you don't have a space, you have to optimize the existing space, enhance the capacity within the available space, available substation space, to cater or to have more capacity. At the grid level, when I say grid means 66 by 11 or 33 by 11. So we are operating at 66 also and 33 also. So if you have understanding of Delhi, so within the ring road, it is mostly 33 kV network, and outside the ring road, where which has expanded lately in last 25-30 years, are generally 66 kV network. So which was like built previously in last 20 years. We have built about we have doubled actually number of substations and capacity since we acquired in 2002. If you say 2002, our demand, the peak demand, has grown more than 3 times, and to serve those demand, we have added capacity of similar order at every level, like 66, then 11 kV and LT, the line capacity as well as the transformation capacity. We have also achieved the loss of about 6%, starting with about 55 to 60% as a BSE as a whole. So that journey from 60% to 6% is like we achieved in last 22 years. Our customer growth in the new area like West Delhi, if you have the geographical understanding, so West Delhi is still growing, and this horizontal growth requires a lot of electrification, addition of grid, and for that getting a space is a challenge. So we have two kind of problem. One problem is brownfield, the modification of the existing substation, and second one is the adding the new substation in the greenfield in the new areas. In the new area, it is comparatively easy because the load is area is new. We can get the space, and but in the already developed area, getting a space is difficult. So what we started? We started converting AIS system to GIS system so that we can add more power transformers, and we can have more capacity. With recent guidelines of CEA, we can have up to 160 MVA of capacity in 66 by 11 kV substation. So we are trying to reach that capacity because earlier it was restricted to 100 MVA. Now it is going up to 160, and in some of the service stations we are already reaching that even 160 service stations. So AIS to JIS is the one thing which we have adopted, and now our all substations, new substations are GIS substation. So that is helping us in optimizing the space. Recently, we have charged one substation with the 63 MVA of capacity in about 1140 square meter, which is like one of the, high density substation, high capacity density substation. Normally, the regulator recommends 1500 square meters. And another substations we have like packaged or e-house substation. So you have containerized grid wherein all switchgear is within the grid and then power transformer outside. That is also like within 600 square meter, you can have one powerhouse. Then we have also adopted elevated substations. Double pole structure substation was conventional and it is prevalent everywhere. But we have seen that even you don't have space to erect two poles, double pole structure. So what we have done on single pole, DT on the top and switchgear RMU and air circuit breaker underneath. So that saved about 70 to 80% of the space requirement. Elevated substation have many versions. It can be on the four pole structure, two pole structure, single pole structure. Uh, as per the guidelines, oil field transformer can be up to 500 kV. So that is the limitations. But to overcome that, what we have done, we have started using dry type transformer. So you can have transformer on the top and the switchgear underneath. So that we call G plus one, ground plus one substation. As we build our houses, double story houses, so we started building the double story substations. And in these substations, we have 100,000 MVA transformer, two transformer on top, and four-way RMU at the center, and one side air circuit breaker for one set of transformer, and another left side another set. So this way, with like 13.7 square meter of space, we are able to build G plus one substation of 2 MVA with the RMU, HT and LT protection. So this way, conventionally, 79 square meter was required. Now 13 square meters, so roughly 80-85% space, less space will be required for G plus one substation. Uh, Another thing which we have tried is like double decker substation, another version. So you put a normal conventional DT on the top and then switch gears on the underneath. So that saves about, with the similar kind of everything same and every equipment remaining same, only the change in configuration gives is saving the space by about 50%. Similar thing we have adopted in LT switch gear. So we call double decker air circuit breaker. So generally you have air circuit breaker as a string, one after the other, but we have like one on top and one on bottom. We have platform to operate. So this saves the requirement, more lesser space is required in double circuit breakers. On the cable side, we have adopted, or now almost 100% cables on 11 kV is co-extruded cables. So earlier we used to have pipe and then cables. So both are different inventories. And at times we have found that during the laying of those cables, it could not be guaranteed that at every place this HDP pipe was placed. So to overcome that, we have co-extruded this HDP pipe with the cable, and that saved cost also. Laying cost also reduced. And earlier there was a problem of bending radius, but now that has also been addressed. So we are extensively using co-extruded cables for our purposes. So roughly 5 to 600 kilometers of CCD co-extruded cables we are using on daily on yearly basis. Another thing we have tried, and we are now deploying it in full scale, is battery support at the distribution transformer level. So Delhi have peculiar load curve of two peaks during the day. One is during like 3:30 p.m. during the day, and another is like 10 to 11 p.m. at night. So, and those durations are small, and during, if we take yearly like 8760 hours, these hours are very less, so only less than 1% of the time these peaks do occur. So to address that, we have installed the battery support, the modular battery support, to save the peak demand of at the distribution transformer level. We have installed it in 2021. We have observed for now 2 3 years, and we are convinced that this is going to solve our peakier demand. And that, apart from that, not only the capex deferral, but also gives flexibility to install those battery in a modular way, in 12 kilowatt hour modular way. So that we have tried, and we are now extending it for mass implementation. We have also adopted grid connected base at for 20 megawatt 2 hours, so 40 megawatt hour, that has been commissioned and it is ready to operate. And we have all that that will actually solve the multiple problem. One of the problem was problem at the transmission end, so transmission capacity was also constrained. So with 20 megawatt of 2 hour battery, it will directly relieve the transmission STU network, apart from my own 33 by 11 kV grid. So those are the some of the solutions we have adopted to overcome our recent challenges of peak, meeting our demand, giving a reliable supply to our customers, deferring our capex, giving more flexibility in planning through modular adoption of solutions. So in nutshell, we are like adaptive to all the solutions which could be adopted for to serve our customer with a reliable and quality supply.